Hello, everyone. Today we are going to Diffie-Hellman key exchange algorithm. Now, since we have already completed Elgamal in the last class, this is very similar to the Elgamal algorithm. And there are so many other, protocols, public key protocols, which, are very much similar to this Diffie-Hellman key exchange. And one example is NS algorithm. Okay, each has got its own advantages and disadvantages. Some are outdated. So all of them work on the concept that, groups, the exponents of groups, even if they are available, that is earlier you saw in Elgamal, even though G raised to X is available and G raised to Y is available, it is not possible to calculate G raised to AY. Okay. And similar concepts of groups are used to, and discrete logarithm are used to securely transfer messages or blocks of data from one point to another. Okay. Diffie-Hellman algorithm is used specifically for key exchange. So we're going to see how key can be exchanged safely using the groups concept. Okay. Going straight into it. The concept is Diffie-Hellman is used to securely exchange session keys. Okay, so without actually needing to keep what is being exchanged a secret, even if what is being exchanged, that is Oscar or the hacker is able to hack the data which is being transmitted over the public network, they will not be able to calculate the secret keys. Okay, so let's begin. Alice and Bob. First, they agree on two values. One, a large prime n and a number g. Okay, so two values, n and g. G is the group. And g should be a primitive mod of n. Okay, we agree on a large prime and g should be a primitive mod of n. Okay, so these two numbers are agreed upon. And n and g, they don't need to be a secret. Both n and g, even if it is revealed, it will not cause a problem for the key that is being shared. Okay. Now, exchanging a key. What is done to exchange the key? The first step is Alice and Bob wants to set up a session key. So this session key is for that particular session. Every time they want to transfer data, they will have to set up a new key. Okay. How can they learn the key? That means how can both of them have the same shared key without anyone else knowing it? That is where Diffie-Hellman comes in. Okay. The protocol assumes that if the person is able to generate the session key, then they are an authentic user. Okay, so how that is done? We're going to look at that. Alice chooses a large random integer. So Alice and Bob, both of them know n and g. And it is not a secret. Everybody knows n and g. Okay. Then when Alice and Bob wants to send messages or set up a session, what Alice does is Alice chooses a random integer x. And then she calculates g raised to x mod n, because g and n is already known, g raised to x mod n, and sends the x value to Bob. Okay. Then when Bob, needs to do the same thing, Bob also chooses another random value, which will be not something different. It is a random value. So a large integer, random value y, and sends g raised to y mod n to Alice. Okay, so now Alice has got capital X, that is g raised to x mod n, and Bob has got, Alice has got g raised to y mod n, and Bob has got g raised to x mod n. Okay, so capital X and capital Y is now sent to each party. When Alice receives capital Y, what Alice does is Alice calculates y raised to x. X is the value which was randomly selected by Alice. So y raised to x mod n, and Bob computes x raised to y mod n. Okay. So the values, once they have been given, and these two values, both k and k dash, in essence, is g raised to xy mod n. Okay, so the same property which gives security for Elgamal is used over here also. And now both of them have got the session key g raised to xy mod n. Okay, and since it is not possible to find what is g raised to in the values of x and y from g raised to x or g raised to y, and since it is not possible to calculate g raised to xy based on g raised to x, the keys are now known only to the two parties which are communicating. Okay, let's see why. Why can't others get the secret? What do they know? These are the values that they know, everything that we sent over the net. So they know n and g, and then they know the value capital X, that is g raised to x mod n, and capital Y, g raised to y mod n. But from knowing these values, they are not able to compute g raised to xy mod n. That is, earlier you remember in the Elgamal algorithm, we had said that by knowing g raised to x or by knowing g raised to y, it is not possible to compute g raised to xy. Okay, so they don't know x or y. Knowing capital X and Y gets you K. That is, if you have capital X, then you need to know Y to get K. If you have capital Y, then you need to know X to get K. Okay. So knowing the g raised to X and g raised to Y is not able to get us g raised to XY. So they cannot get anything unless they're able to do the discrete logarithm of g raised to X and find X or Y. Okay, which is a hard problem. So they are not able to do it. Okay. So now with this, we are ending Diffie Hellman. And in the next class, we will be going into detail for elliptic curve cryptography. Thank you. And as usual, feel free to contact me if you have any doubts. And don't forget to like and subscribe. Thank you so much.